Ever wonder how AI models like GPT or QN master language so effortlessly? It's not magic, it's all about the data they're trained on. But here's the real puzzle. How do you mix that data to create the strongest possible model? Today, we're exploring a breakthrough called Domain2Vec, a method that redefines how we optimize training data without ever training a model. Think of it as a digital recipe book that calculates the perfect ingredient ratios using math, not guesswork. Let's unpack how it works. First, let's address the problem. Traditional data curation is like cooking by intuition. You throw in news articles, code, and social media, hoping it all blends well. But this approach is inefficient, hard to scale, and fails when data shifts. It's like baking a cake without knowing the right flour-to-sugar ratio. Enter Domain2Vec. This technique acts as a digital chef's knife, slicing through data chaos. Instead of trial and error, it breaks datasets into metadomains, fundamental text categories like scientific papers, code, or social media. These metadomains are the building blocks of language, each with unique patterns and structures. Here's the key insight. Domain2Vec converts each dataset into a vector, a mathematical fingerprint that captures its metadomain composition. Imagine these vectors as directions on a map. If you want to mix datasets, you combine their directions. The magic lies in the distribution alignment assumption, DA2. If your training data and validation data look alike in this vector space, the model learns faster and performs better. And here's the kicker. You don't need to train a model to find this optimal mix. By aligning vectors, Domain2Vec predicts the best data combination using statistical patterns alone. It's like mixing paint colors. Knowing the exact shade of each pigment lets you predict the final hue without trial and error. Let's talk results. In experiments, Domain2Vec achieved the same performance as traditional methods, but used just 51.5% of the computation. That's like baking a cake with half the ingredients. Under the same compute budget, it boosted task performance by 2.83% on average. Plus, it's scalable, adding new data sources. No problem. The system adapts automatically. How does this work in practice? Imagine building a library. You want diversity, but need to avoid redundancy. Researchers call this a spanning set, a collection that's both comprehensive and non-redundant. In this study, they focused on English and Chinese texts, ensuring datasets were linearly independent, like avoiding duplicate books. They used k-means clustering to group similar texts and embeddings, digital fingerprints that measure textual similarity. The result? A colorful map showing how much each dataset fits into categories like science, code, or news. Here's the breakthrough. Each dataset becomes a domain vector, a mathematical representation of its identity. Think of it as a color code for books. Each dataset has a unique signature. By analyzing these signatures, Domain2Vec identifies the optimal mix without ever training a model. So why does this matter? Traditional methods require massive computational resources to test data combinations. Domain2Vec skips the training step entirely, using statistical patterns to predict the best mix. This isn't just faster, it's smarter. By understanding how datasets interact, we can build specialized AI systems for fields like healthcare or law, tailored to their unique data needs. Next time you chat with an AI, remember, behind the scenes, researchers are fine-tuning the perfect data recipe. Tools like Domain2Vec are making this process more efficient, precise, and adaptable. Thanks for watching, stay curious, and let's keep exploring the future of AI together.